Hi folks, this is Calc 2, Checkpoint Quiz 9. In number 1, we're given a pair of integrals that look hauntingly similar, and we're going to discuss or see that the integration of these two animals is entirely different. So let's start in part A. We've got the integral of 1 over the square root of x squared minus 25 dx. And so we think back to the integration formulas we know and see if this matches any of those directly, or if we can get to one of those with a u substitution, and none of them check. The arc sign is hauntingly close, but in arc sign it's the constant squared minus the variable squared. Okay, this does remind us though of arc secant. In arc secant we have a square root with the variable minus a constant, but we're missing the other variable out front. And so we're going to make a trigonometric substitution. Let x equal the constant, which is being squared here, 5 times the secant of theta. So the dx then is 5 times the secant of theta times the tangent of theta d theta. It's important for us to remember the values that theta takes on, because our book uses the range of the arc secant function as quadrants 1 and quadrant 2. This substitution is good for thetas in those quadrants. So this is valid for theta between pi over 0 and pi over 2, as well as pi over 2 and pi. And not all books are like this. And we'll see that this momentarily is going to cause a wrinkle in what we're doing. All right. So we'll go ahead and make the substitution. And so what do we get? We're going to get, we substitute x in there. We're going to get the square root of x squared 5 secant theta squared minus 25 times dx 5 secant theta tangent theta d theta. So this is equal to the integral of numerator 5 secant theta tangent theta, denominator I get the square root of 25 secant squared theta minus 25 d theta. So I go and look at this, and the whole reason we did the secant substitution is to make use of the Pythagorean identity that secant squared minus 1 is tangent squared. So if I multiply this by 25, 25 secant squared minus 25 is 25 tangent squared. So all the trigonometric substitutions, the whole point of all of them is to take a two-term, what's underneath the radical that's in two terms, and replace it with a perfect square that's just one term. So this is 5 times the secant of theta, tangent of theta, all divided by the square root of 25 tangent squared theta, d theta. And so I get 5 secant theta tangent theta divided by the square root of 25 is 5. The square root of tangent squared is the absolute value, tangent theta d theta. So the 5's cancel out, that's no problem, but it's the absolute value of tangent here that we have to be concerned about. Because of how our book defines the range of the arcsecant function, if we're in quadrant 1, which is where these thetas are running around, in quadrant 1, tangent's positive. So the absolute value of tangent's just tangent. But in quadrant 2, the tangent's negative. So the absolute value of tangent is the opposite of tangent. Now, more often than not, these two cases will come out in the wash, and you can just pretty much ignore them. But there, as we mentioned in class, there is some cases where it doesn't happen that way, and so we do have to be careful. As far as the calculus is concerned, one case is just going to be the opposite of the other, so it's not going to be that big of a deal, but we still need to pay some attention to it. All right, so in the quadrant 1 case, the integral I started with becomes this integral. And in quadrant 1, the tangent's positive, which means the tangents cancel, and I'm just left with the integral secant theta d theta. And we have a couple choices for this integral, but one of them is the natural log of the absolute value of secant plus tangent, plus c. So to get this back in terms of the x's, what do I need to do? I need to remember the substitution. X is 5 secant theta, or in other words, the secant of theta is x over 5. So looking at my antiderivative, to convert this back, I've got the natural log of the absolute value. Secant of theta I know is x over 5, plus, now I've got to figure out what the tangent of theta is. So I'll go back to my Pythagorean identity. I know that tangent squared theta is secant squared minus 1, and secant's x over 5. So this is x squared over 25 minus 1, which is x squared minus 25 over 25. So for the tangent of theta, I get plus or minus the square root of this thing. Which is plus or minus the square root of x squared minus 25 over 5. Since I'm in quadrant 1 and the tangent's positive, I'll choose the positive square root, and so I get this. And while there's nothing wrong with this, we can actually simplify this to the natural log of the absolute value of x plus the square root, x squared minus 25 over 5 plus c. And I can use log properties. So natural log, absolute value, x plus the square root, x squared minus 25, minus the natural log of 5, using the quotient rule. And the minus natural log 5 I can absorb into that arbitrary constant and get this answer. Now, I could actually get rid of the absolute values, because in quadrant 1, right, in quadrant 1, the secant's positive, which means that the x here is positive. So I could actually get rid of the absolute values, but I'm not going to because of what's going to happen in case 2. So this is our answer for case 1.